Let's say you got a dog or cat, doesn't matter. I'm a dog person, and for this video, I'll call him Bolt maybe. So you're trying to teach Bolt. There are three ways you can try. The first way is that you can give examples and he can learn from your examples. So you can basically say, oh, this is right to do or this is wrong to do. So you should do this or you should not do this. The second way is that you can let him to discover patterns himself. And the last way is that you can leave Bolt in some situation and he will get rewarded based on the actions he takes. So believe me or not, but these three ways are the major ways how the machines learn. Let's start with supervised learning. Look at the pictures. We have three different poses, right? The first image is a sitting pose, second one is rollover pose, and the last one is jumping pose. So you will show these examples to your dog and you will tell him, okay, first image, look at this dog, this is sitting. The second image, look at this dog, this is the rollover, and so on. So in other words, we can say that you give your input and also your output to the model or to your dog, doesn't matter. Later on, we will learn about features and label, but for now, you can just assume it as the input and output. So for the supervised learning, you have to provide your model with both input and also output. There are some real world examples that I mentioned on the bottom. We already talked about email spam detection, right? So what you have to do, you have to provide the examples of real emails and also provide the examples of fake emails. So you have to give both input, which is emails, and output. And output is the class or label which says if the email is real or not. Now imagine your dog is in the room with different objects like balls, sticks, bones, or ropes, okay? And nobody tell him what they are, okay? You're not gonna tell him that this is ball, this is stick, this is bone. You will not say anything. All you have to do, you will just leave your dog there and he will start to explore all of these objects. And after a while, he'll start to explore the similarities between some objects. So Bolt will start to group toys by similarity. For example, round objects in a one group, long stick-like objects in another group, and rope-like objects in another group. There is no labels, there is no answers, just patterns. That's unsupervised learning. You only give your input, which I mean objects, and you don't tell what they are. And your dog will start to explore the similarities and patterns between these objects. Unsupervised learning is discovery based. It finds the structure even if we didn't know that it was there. And finally, imagine your dog is learning how to play fetch. At first, he doesn't know what to do. He's just wandering around, right? Sometimes grabbing the stick, sometimes running the wrong direction. He doesn't know what is right and what is wrong. But every time when he does something good, you give him a reward. Let's say he brings you ball back, then you will give the reward. And every time he makes a mistake, he gets no food. By this way, your dog learns through trial and error. That's why actually reinforcement learning is very powerful, because it keeps improving based on the feedback. So after the taken action, if he gets a reward, he realized that he did a good thing and he improved himself. But otherwise, if he doesn't get any reward, he understands that he was not supposed to do it. And next time he doesn't repeat the same mistake. It's like a baby who touched the fire for the first time. Until first time, baby doesn't know that fire hurts, right? But only one time, when he gets hurt, he knows that next time he's not supposed to touch the fire. These three things are the major ways for the machines to learn. Once you master these three ideas, the whole world of machine learning becomes much easier to navigate. There is no such a thing like this one is better than the other one. It really depends on the case, on the situation, like what dataset you have, what's the requirements, what's the output expectation. So you will be using each way for different cases, but it is important to make sure that you know all of them.